My name is Cynthia Brazel, and I am the CSO of Aequor. My background is in marine and medical microbiology, and my expertise is with contamination control in biofilms. Bacteria have hitchhiked up to the ISS, where they quickly develop resistance, degrade equipment, and contaminate life support systems, threatening astronaut health, long-term space travel, future space living, and cross-contamination back to Earth. The bacteria in the ISS water systems have become resistant to silver, the antimicrobial of choice, and form biofilm slime. And it has already resulted in loss of hardware, impact to system operations, and increased resupply. These images are of the water recovery system that recycles wastewater, including urine, back into potable water. And the image on the left is a pipe clogged with biofilm. To tell you why Aequor is uniquely positioned in this space, I will take you back to our origin story. I discovered novel bacteria from the coral reef environment that produce natural antimicrobials. Aequor's treatments either kill or inhibit the growth of a wide range of bacteria and fungi that contaminate surfaces and water, including several resistant strains. Aequor's portfolio also contains chemical analogs that mimic the natural chemical, and several are GRAS or FDA food additives. We wanted to understand if Aequor's treatments would be effective against 3 difficult-to-treat biofilm-forming bacteria isolated from the ISS water system, including the silver-resistant strain. The testing took place in 2 different phases, both at Aequor's lab and at the Marshall Space Flight Center. Phase 1 was a laboratory series of antimicrobial and antibiofilm tests. 8 of Aequor's treatments were tested to select a treatment that performed the best, and treatment A1026 was selected for Phase 2. For Phase 2, 5 55-liter tanks were filled with wastewater ersatz and the mixed bacterial inoculum. The schematic on the right is of the water processor assembly. The tanks periodically cycled back and forth from a transfer tank, mimicking the cycling process on the ISS. For Phase 2, Aequor's A1026 treatment killed 99.999% of the bacteria the first day and maintained activity for 15 months. Tanks 2 and 3 have the same concentration, and Tank 4 had a lower concentration. We also saw a dose-dependent curve in Phase 1 on the smaller scale studies. For biofilm prevention imaging analysis, we stained the live cells green with cyto9 green fluorescent nucleic acid stain and dead cells red with propydium iodide. The image on the left is the control, showing thick biofilm that stained green. The image in the middle is a dose of A1026 that inhibited biofilm formation but did not kill all the cells, and these cells are washed off easily. The image on the right shows a dose of A1026 that killed the cells, and you can see they appear red. To determine stability of A1026 in the tanks, a calibration curve of different concentrations of A1026 was developed, and samples were measured throughout the study. The calibration curve was used to determine the concentration of A1026 remaining in tanks 2 to 4. You can see the slight degradation of A1026 over 15 months. The amounts of the treatment that remained are more than sufficient to maintain antimicrobial and antibiofilm activity. Aequor won the NASA iTech Award in the life support category, and we are participating in the Catalyst program with aerospace prime contractors. The image on the right is a paper presented by Marshall at the 2019 International Conference on Engineering Sciences. This slide is of astronauts drinking recycled water on the space station. And NASA outlines in the Human Adaptation to Spaceflight, the role of food and nutrition, that the ability to reclaim water from urine will be an absolute requirement for exploration class missions. The impacts that this has are de-risking the threats to astronaut health associated with contamination, improving the integrity of equipment by preventing degradation, providing an option for a multifaceted approach, and overall de-risking the mission. I wanted to acknowledge the folks at Marshall and microbiologists at Boeing who provided the bacteria, and I wanted to thank the AAS, ISS, and NASA for this opportunity. Please contact me if you have any interest. Thank you.